Hey, thanks for joining. In this tutorial, I'll be talking about Lofts in OpenCascade technology kernel, and I'll be using this Rete Editor that you see here to illustrate how Lofts can be used. So let's get started. Let's create a skybox here. Let's also draw a grid mesh on the screen so that we have some ground. And also let's create directional light. And I'll just change its intensity to 3. Now let's create an ellipse. So you can also find the ellipse here by going to OCCT, shapes, wire, and then primitives, and here's the ellipse. Yeah, let's just use that. You'll see that it's practically the same thing. So we've created an ellipse wire now, and I need 3 of those to illustrate the first loft command that we'll be using. So now I have 3 ellipses. They're all exactly the same. So I'll just move them into different heights. Let's do that. Let's say that this one will be on 3. And this one will be on 5 or 6 maybe. Let's keep it on the same interval. Okay. And now I will also make sure that this middle ellipse is bigger, like maybe 4 and 2. Or 1.5 maybe, like this. Then this ellipse will be the smallest one, so 1 and 5. And then this bottom ellipse will be something like that. So we have now 3 ellipses in space, right? This is quite simple to understand, I guess. And now what we want to do is we want to create a surface or a face, right, that joins all of these ellipses together. So to do that, we will be using OCCT operation called Loft, and it's in here. So let's just use the simple one, Loft. You see that it doesn't have many options here. It just has this list of shapes that it expects to get, and we can choose if we want to make a solid out of it. So let's see how that works. First of all, we will need to create a list like that. And we will need to put all of our ellipses into this list like this. So from the bottom to the top. And then we will just plug this wire into the shapes. And you'll see that now we have created this, well, a beautiful face that connects all of these wires, right? And if we want to make a solid out of it, so we just do this, and now it became a solid. You see that the bottom face was created and the top face was created. So this is really useful because you can then just 3D print this or do something interesting with it. So you can also, instead of making a solid, you can create a thick solid like this. So you just thicken the loft, and yeah, this is a bit too extreme maybe, but let's do 0.5. And you see now that it's also a solid, but now that face that we've created was used to sort of offset everything outside, and it creates a good looking result as well. Yeah, so if you need more options in Loft, you can use another Loft command. So let's go back to OCCT. You see that Lofts has this Loft advanced command here. And this one has way more options to choose from, and I'm not going to go through all of them, but let's just investigate a few of those. So let's now again plug the shapes into it, and you see that it just works exactly the same as the previous one. But now you can also say that you maybe want a straight loft, and in this situation it will just create these straight sections between the ellipses. And this is also something that you may want, right? In this situation, you can even go and say, okay, I want to also then fillet edges. So you do something like that. And you hide the first result, maybe like that. Okay, so you see that now basically the fillet was created here on the corners, which may be also an effect that you're looking for. We've experimented with this straight approach. You can also use the solid, so don't forget to make it visible again. And this is working exactly in the way that the previous component worked. What's unique about this component though is that you can also create a closed loft. So this would do something like that. You see that now face generated sort of bends into itself. Basically what happens is that the face is using the first and last ellipse as the start and end point to itself. So this is also sometimes useful. Another thing that you can do is use these start and end vertices. These are quite useful if you want to end the loft in some point. And let's just do that. So let's use vector xyz. And I know that I've started on 0, but I want my start point to be on -2 then. And I'll use this like that. And let's also see how high is our last ellipse. So it's on 6. So let's put it on 8. And let's connect this like that. So now you see that, yeah, this is a bit too high. Like it solved it not in a very good way maybe, but what we can do is just lower it a little like that. And this is much better. On the bottom it looks quite okay. So you have this effect where the loft goes into a single point. And this is also quite useful sometimes, right? So another option that we have here is these periodic lofts. And the periodic loft just uses initial ellipses and creates sort of closed periodic loops that it will loft. So it sort of changes direction and everything. So it's a bit hard to explain maybe, but we can just look into effects. So periodic lofts only work with closed lofts option. And we can just use this. And in this situation, we also need to, you see that, yeah, this is almost good, but the face is inverse. So you need to just reverse initial ellipse list like this. And then you'll get the better result. So you see that now it sort of looks not maybe really correct because it's self-intersecting. But what we can do is, you know, just maybe make those ellipses a bit smaller. So like this, and that will just look better probably. So let's keep it on 3. Okay, so you get the point. Now it's not closing on one point here. It forms this interpolated periodic section, and then it lofts those around the ellipses, and it creates a bit different result basically. And you can also choose how many of those you want. So, I mean, if you just do 4, for example, your results will not be very accurate. And if you do like 40, they will be accurate, but they will be also quite a bit more heavy. Sorry to interrupt. In case you don't know me, I'm Matas, the founder of Bitbybit. I hope you enjoyed this video, and if you do, please hit that like button and subscribe to our YouTube channel. I also want to offer you a small deal. Because you're watching this video, I assume that you're using Bitbybit platform too. Here's the promo code that will give you a small discount to our silver and gold plans. With these plans, you gain access to our cloud infrastructure, 3D configurators, and other advanced features. Your subscription also helps me develop the content, such as this video that you're watching right now. It also helps me develop Bitbybit platform and keep majority of its features free and open source to everyone. Your support means a lot to me. I hope you'll consider the offer, and let's continue with the video. So another important thing to understand about loft is that amount of edges on the wire that you're trying to loft needs to be exactly the same across all the cross sections. So for ellipses, it just works fine because ellipse is one edge, right? And if you have some more complex geometry, I'll just now get rid of all of that. Let's just keep these coordinates. We will need them, but let's create, you know, a different primitive. Let's create a shape of a wire, but let's go and do a star. So now I have a star here, and I will also make sure then that I have a star that is also higher, and a star that is even higher than that. So now if you just change, you know, the radius, for example, to 3, and maybe you want to also change it here to something like 4. You can create a loft as you did before, so we will create a list like that. And again, let's just loft it. Yeah, so the direction of the star is probably different from the direction of the ellipse, so we need to reverse the list like this. And let's do that. Okay, so now you see that I've created a loft, and it works fine because the number of edges on each of the stars is the same. But if I sort of change that, so for example, I say that the number of rays on the star should be 4, you see that now loft failed, and it failed because the amount of those edges is not equal. And this also happens when you are trying to loft, for example, a shape that is maybe filleted. So let's do that. I'll just return this to 7. And then let's use, instead of, this bottom shape here, I will say that round this bottom star, fillet 2D, like this, and let's use maybe 0.2. So now what we will be trying to do is use this filleted wire and loft it together with other wires. So let's just connect everything like that. And you see that it just failed. And also when we tried to loft it against, just first and last one, it did create the result, but it's definitely not the result that we were looking for probably. What it did, it just sort of took first edge and lofted it for the first of the other star, the second with the second, and you see that it just didn't work well. So if you want to make it work well, you will need to use these fillets on all of the stars, right? And you will need to create it like this. So in this way you create wires that have equal number of edges. And now, because of that, you can use create list. And let's go like that. Let's connect the list to lists. And let's also hide some things here so that they don't intervene with our visualization. And now you see that we've created a nice looking shape here. It's sort of driven by these stars that we've lofted. So I hope I went through majority of the cases where loft can be useful and explained in principle how it all works. I mean, in situations that you see these kinds of results where faces are inverted, it usually just means that you need to reverse the order of your wires that you provide, into the loft command, and that solves it. Otherwise, you need to also just reverse all of the faces that you generate from the loft, which, I mean, is also possible, but is just a bit more involved. And in this case, of course, as well with other ellipse variants, you can create the closed lofts. And yeah, these are quite useful, I think. I hope you enjoyed this tutorial, and I hope to see you around next time. Cheers!